Hello, everybody. Welcome back to the third episode of our webinar. In the last episode, we went through some of the most important features of PVD technologies. As a result, today we will be introducing Optitune's nanocoatings with a particular focus on TPD series. This is a part, of course, of our portfolio. TPD nanocoatings are usually solvent-based polysiloxane formulations, which are applied according to a monolayer structure to a diverse range of surfaces and materials. For example, when it comes down to electronic displays, everything that has to do with displays and screens that can be easily scratched is a good candidate for TPD, which can improve these kind of surfaces by making them abrasion resistant. But also, another really suitable application is related to home appliances and kitchen appliances. And as we can see in this picture on the right, everything in the household that can be easily scratched or that can be exposed to intensive usage can be better protected by our TPD nanocoatings, which can make these kind of materials easier to clean, oleophobic, hydrophobic, and abrasion resistant as well. Let's say that in other cases, our portfolio of nanocoatings, which are not part of the TPD family, can enrich optical properties as well. And this is particularly interesting in the case of electronic displays, for example. Let's now focus on steel. We know that there are different kinds of steel, of course, and their properties depend largely on the alligation elements. But usually it's not easy to find a steel that exhibits properties like hydrophobicity, oleophobicity, salt corrosion resistance, no fingerprintability, abrasion resistance. By applying TPD series 500 to uncoated steel, we can enrich this material by providing it with all of these properties. In particular, in terms of salt corrosion resistance, Optitune has obtained C5 medium classification according to ISO 12944 by Kiwa when applying our nanocoatings to galvanized steel. These properties, in the case of TPD, are also preserved under thermal exposure and chemical attack by agents that are commonly used in the household. We can say that these properties are a given in the case of the treated materials because our laboratory in Oulu is equipped with many different methodologies of tests. For example, we can quantify the abrasion resistance through the so-called linear Tabor tester. This tool is equipped with the heads that can be coupled with different materials like steel wools or cotton cloths. And these get into contact with the surface and they strike backward and forward along the same line. In this way, the abrasion resistance is quantified in terms of numbers of strokes. And the hardness of the coating can be easily gauged through the pencil hardness tester, which is usually equipped with a pencil, of course, whose tip can have varying hardness values. And this pencil gets into contact with the surface to be tested, which can get scratched. And then, depending on the particular kind of scratch that one observes, we can quantify the hardness of our coating. The hydrophobicity is quantified through the so-called WCA meter, This is a tool that releases some drops of water on the treated surface. Then it can analyze as well the water contact angle, WCA. And in the case of TPD nanocoatings, we are usually at a WCA larger than 110. The oleophobicity is usually gauged through the oil pen test. In this case, we take a normal marker, oil pen marker, and we can draw a line on the surface. Over here in the picture, we can see on the left a treated surface, and on the right an untreated one. And it's clear that the TPD coated one cannot be easily, let's say, imprinted by this marker. All of these properties, of course, are preserved under important thermal stress, and this can be verified through baking tests and boiling tests, but they are also resistant to chemicals that are commonly used in the household, for example, in cleaning products. Now we can have a look at some of the properties, and we can have an idea which is, let's say, more practical of what our TPD nanocoatings can do. This is an untreated surface, and this is a treated one with a TPD, which can be easily cleaned and wiped. And here we can see also hydrophobicity. Let's now take a look at a frying pan and at oleophobicity and easiness to clean. And finally, we can have a look also at hydrophobicity. With another liquid other than water. Here we can see also the easiness to clean.